Hello everyone, my name is Mahdi Yusuf from Electronic and Computer Engineering, and today I will present to you about a paper for knowledge-based system midterm. So the paper that I want to talk about is about the deep fuzzy hashing network for efficient image retrieval. This is a paper by Liu Hemin from the Kyushu Institute of Technology that published in IEEE Transaction on Fuzzy System. So the overview of this presentation is there are three parts. The first part is the introduction. I will talk about the image retrieval and hashing method. And the second part is the proposed method by this paper, which is the deep fuzzy hashing network. And for the third part, this is the result for this paper experimental result and the conclusion of this research. For the first part, I will present about what is the problem that this paper wants to solve and the background about that problem. So the problem that this paper want to solve is image retrieval. So image retrieval is some kind of problem when we want to find an image with similar visual content on the image database. So for that task, we need to provide a query image into the system, and then from the system, they will provide the retrieval image, which is the image that have the same similar visual content based on the query image. So this problem can be defined as the content-based image retrieval, where we provide an image to the retrieval system, and then the retrieval system provide the image that have similar content in the visual semantic space. For solving the search problem, the image database, we can use the hash function. So the hash function is actually just a transformation of the input data with the hashing algorithm or hashing function into the output hash. So this output hash is corresponding to the image. So if we input the same image, we will have the same key from the image. So this hashing problem, we must create a hashing algorithm that the we can use to generate key based on the input image. So this hashing task is reducing the complexity of searching in the image database. So this is the example of that uh, problem. So if we want to use a key to find in the database by using the sequential search, we must iterate through the database and find the same key value in the database. So the complexity will be big O of n, and with the binary search, we can reduce to big O log 2 n. And if we use the hash function, we can generate the key from that generate the key hash value based on the key using the hash function, and we can just look into the index that uh, pointed by the hash value in our key. So that will be that will reducing the complexity of the searching problem. And the problem for the hashing, that can we just use the current hashing function, which is the MD5 maybe or SHA, into the image? The answer is no, because if we modify the image and perform the hashing using uh, the current hashing function, and the hashing will be very different between the image in top and in the bottom if we resize the image, and that can be a problem because we want the hash from the same similar semantic image have the same similar hash value. We don't want this hash value and this hash value will be very different. So the question is how to represent the image feature in the hash that not affected by any variance. Maybe if we resize the image, the hash will be having a similar value, or if we rotate and blur the image, the hash will always be a similar hash value with the original image. And that is the problem that this paper want to solve, that how to generate the hash function that project the image from the high dimensional into the low dimensional space, which is the binary hash value. So based on the problem that we have defined, this paper is proposing a method to solve that problem. But before entering to that, we will try to learn about the previous work in this task. For the first example, they use the two-stage network as the learning process. In the first stage, they learn the approximate hash code. They learn about how to generate the hash code. And for the second stage, they learn the image feature and the hash function to generate the hash. So there is no explicit feedback loop between these two stages. So that is the weakness of this two-stage network. And this can be uh, modified into a single stage network to learn about the image feature and the hash code simultaneously. So this is another example of the previous work, which is the one stage network with triplets. So we have the key positive pairs and negative pairs that entered into the network. These networks have the shared uh, convolutional neural areas, and from the features generated based on this convolutional neural network, we use the divide and encode module to generate hash code. And based on that hash code, we will try to find the loss by using the triple ranking loss function. This is also a one-stage network to learn about the image retrieval task. So they use multi-label image to generate a, a semantic ranking, and they use that semantic ranking to supervise the learning in the convolutional neural network. So they have a multi-label in single image, and they provide the ranking which is based on how similar the query image and the image that have the label. And by combining this, they preserve the multi-level semantic similarity between the multi-level image to generate the hash code. But all this previous work is work uh, heavily rely on the sophisticated deep neural network model to capture the complex image data, but they ignore the data structure of the image. So they also utilize the label information as the supervision rather than visual or semantic similarity. So the model is doesn't have the visual or semantic similarity uh, representation, and this would reduce the effectiveness of the learned binary hash code that are supposed to preserve the similarity cues in the image. So the main contribution from this paper is they try to combine the fuzzy logic into the deep neural network to learn about the binary hash code for image retrieval tasks. They propose a network called Deep Fuzzy Hashing Network to perform image feature and hash code learning, and that use the deep neural network architecture. But they also reduce the uncertainty of the data by using the fuzzy logic rules in the neural network. Can improve the computational efficiency by changing the convolutional and fully connected layer uh, using another output, which is the generalized Hamming distance between the inputs and the weight. So this is the proposed method by this paper. So they create a deep learning module to generate the hash code based on the query image, and then they also modify the convolutional and the fully connected layer to use the fuzzy rules. So they change the operation in the neuron to use the fuzzy rules. We will try to learn about this exact method in the next slide. So for the fuzzy inference in the neural network, they utilize the fuzzy logic SOR as the neuron output in the deep neural network. So this is the example of the operation of SOR for two element P and Q. So the for finding the result of the SOR operation for P and Q, we can use this equation. And based on this equation, for the P element only, if we want to sort element P with the P, and then the result will be have two rows of condition, and therefore the fuzzy region is from 0 and 1. And by extending that equation into a group, we can still find the direct sum of the sort operation in group follow the sort rules, which is the sort operation on the group divided by the length of the group. So if we have x and y with length of L, the sort operation between the two elements is the sort operation of each element, and then divided by the length of that element. So if we simplify the mean of the element, which is the sum of the x and y, and divided by L, we can generate a function to simplify the sort operation between the x and y, which is the mean of the x plus mean of the y minus 2 divided by length of the element, and then multiplied by the dot product between the x and y, where the dot product is just uh, a multiplication between the each element in the x and y element. So for generating the hash, they create a CNN that can produce the binary hash code based on the image feature. And this hash that generated from the CNN should be similar from the same image class. The hash code should be similar in the Hamming space, and this process of the encoding should be efficient. For that reason, they provide a loss function, and this is the loss function of this network. For the provided hash code from the first image and second image, we can have a T element, and this T element, if the two image is from the same class, they will be 0, and if they are from different class, they will be 1. And this section of the equation is the equation for the distance from the same class, and this second part of the equation is the equation for the different class. So if they are different class, they will maximize this term, and they do that by using this amp threshold value. So if they exceed this value, the loss in here will be higher. And for the last part is the Euclidean distance between the first hash code and the second hash code. So this two hash code should be in the near Euclidean distance. So the last part is about how to combine the fuzzy logic into the neural network based on the previous part. So they perform that by fuzzifying the operation in each neuron. So they change the weight calculation in the neuron using the sort operation between the weight and the input. So if you have know that in the normal neuron, the inference calculation is the uh, multiplying the weight by the x and then adding the bias. But in this proposed method, they perform the sort operation between the weight and the input and then adding the bias. So we just change the x and y in the previous equation with the weight and the input. So and then we can get the inverse output of the sort operation between the weight and the input. And for the bias, we can divide this equation by 2, uh, 2 divided by L, and then we can get this bias equation. And then the full equation of the inference will be the sort operation of this, and then added by the bias. And based on the proposed method, they provide the experimental testing on two kind of dataset, and they try to see how the proposed method performs on the image retrieval task compared to the previous work. So the testing is performed on the CFAR10 dataset and the NUST dataset. And for the CFAR10, this is the dataset with the single image one class label. And for the NUST dataset, they have multiple label in the single image. And for the CFAR10, they have 10 classes, and for the NUST they just select most frequent cases, which is they find the 21 most frequent cases in the classes in this dataset, and they try to compare these a proposed method, which is the diffusive hashing network, with 9 previous methods for the image retrieval task. And the metrics that they use MAP and the precision recall curve for comparing the performance of the model. So for doing that, they use the query from output in the model, and they compare it with the label. And for the AP, for each row in this result, the delta key here will be 0 if the label and the query is different. And so if more and more classes doesn't represent in the same row, the AP will be lower. So based on the experimental settings that we have been defined before, they provide the result on the CFAR10 and the NUST dataset. And these bits numbers means the length of the binary hash code in the binary codes. So 12 bits mean the length of the binary hash code is the 12th binary number. And as you can see that this performance that the proposed method provided, that they have better performance compared to the previous method. And as you can see, for the 12 bits cases, this method is outperformed the previous work by like 3% on the CFAR10 dataset and like 7% on the NUST dataset. You also can see in the precision recall curve that this method is having a better performance compared to the previous work. And based on the number of bits that they use in the binary hash code, The precision is higher if they use the 24 number of uh, length of binary hash. So they use this number as the testing in their model. And they also perform the ablation study of the regular regularizer alpha value in the proposed method. This alpha means the the importance of the Hamming distance between uh, uh, the two hash codes. So uh, this is defined in the loss function. So if they use the alpha 0, there are no importance of the Hamming distance in the loss function equation. So based on that alpha value, we can see that the 0.01 is having a higher performance, a higher result in the CVAR10 performance. So they use this alpha value on all of these testing. So they use alpha 0.01, and this is also the another ablation study of the this proposed method. So they change the which one they used as the fusified layer. So if in this column they change the convolutional layer only, and in this uh, row in this column they use the fully connected layer only. So that means in this testing, the sort operation is performed on the convolutional neuron, but in the fully connected they didn't perform the sort operation. They just perform the normal operation of input and wait, and the vice versa for the fully connected. They perform the fuzzy SOR operation on the fully connected layer, but in the convolutional they perform the normal operation. So as you can see that the convolutional layer is having a much more importance if they use the fuzzified sort operation in the neuron. As you can see, because there are more convolutional layer and there are more convolutional operation, convolutional neuron in the network. So if they remove the fuzzy operation in the convolutional, the performance will drop, and the model will not learn enough representation using the fuzzified layer. And this is the visualization of the inference in the proposed method. So as you can see that if we query this kind of image, which is sunset, window, tree, and beach image, the model will return a list uh, of a image which is retrieved from the database, and they rank it, and they get the top 10 retrieved image based on that ranking. As you can see that all the image retrieved by the model is from the same class, from for the sunset, window, and the beach. But for the tree there are misclassified one, which is this image, and as you can see, overall performance of this image retrieval task, they perform very good to retrieve the image from the database. For conclusion, this proposed deep fuzzy hashing network can integrate the fuzzy logic technique and the deep neural network architecture. This proposed deep fuzzy hashing network can learn more effective binary hash code and capture more uncertainty of the image data.
And they perform this by changing the output of the neuron in the differentiation network, uh, uh, and changing that using generalized Hamming distance in fuzzy logic rules, which is the sort operation between the inputs and the weights. They also provide the new loss function to generate the binary hash code. So this is the main reference that I use in creating this video, and thank you for your attention. And if you have any question, maybe you can find me on this email.